Water we know exists in three states: in solid, liquid and gaseous. When we freeze in a freezer at a 0 degree centigrade, it turns to ice, which is in solid form. When you heat it up to 100 degree centigrade, it converted into the vapor state, that is known as gaseous state of water. In common life, in more amount, we generally use water is in liquid form. In freeze state, it is found on the earth. So water exists in three states: solid, liquid and gaseous. Water is one of the liquid in this universe which can dissolve solid, liquid and even gaseous also. When distilled water sealed in a glass bottle for a long time, we can observe itches on the surface of glass bottle. This indicates even glass, maybe in small amount, can able to dissolve in water. So that water is called a universal solvent. Physical properties of water. Water has no color, colorless. It has no odor, odorless. It has no taste, tasteless. Pure water is colorless, odorless and tasteless. But in daily life, we have experienced taste of water. Taste of water is due to presence of impurities present in it. Impurities may be gaseous or solid. Boiling point of any liquid, temperature at which vapor pressure of the liquid becomes equal to atmospheric pressure. Pure water boils at 100 degree centigrade. But when we go in mountains, water boils at low temperature because on mountains atmospheric pressure decreases. And when we boil water, vapor pressure of liquid at a lower temperature becomes equal to atmospheric pressure. So we have observed boiling point of water less than 100 degree centigrade in the hills. When we add impurities in water, boiling point increases. When we apply pressure on a liquid, molecules come together, force of attraction increases. Then we need more energy to break down this bond. Boiling point increases. All liquid, when start to cool down, it shrinks in size. Size will decreases. Water also shrink in size up to 4 degrees centigrade. But at 4 degrees centigrade, it starts to expand. Their density decreases. We can say at 4 degrees centigrade, water has maximum density. And it starts to expand in size up to 0 degrees centigrade. Until it converted into ice. This is an enormous expansion of water. Water, when cooled at 4 degrees centigrade, it starts expanding and continue its expansion up to 0 degree Celsius. It has a maximum density at 4 degrees centigrade. At 4 degrees centigrade, it starts to sink because of maximum density. an upper layer in a lake converted into ice. This enables marine animals to live in cold region. Even water freezes at the top and liquid remains below the ice layer because water has maximum density at 4 degrees centigrade. At a time it sinks down, and as temperature will be decreases up to 0 degrees centigrade, it converted into ice. This is anomalous expansion of water. At 4 degrees centigrade, as I have told you, it has a maximum density, minimum volume. Its expansion starts at 4 degrees centigrade. It becomes 92 volume of the water, becomes 100 volume of ice. At a time, relative density of ice being 0.92. Next property is latent heat of fusion. When you provide heat to ice, it converted into water. The amount of heat required to convert ice into water is known as latent heat of fusion. Same amount of heat is released when 1 gram of water solidifies into 1 gram of ice. That is known as latent heat of solidification. We know that lakes and rivers do not freeze suddenly because water needs more energy for freezing, and this energy is known as the specific latent heat of solidification. Due to high specific latent heat of solidification, lakes and rivers do not freeze suddenly. As during hot weather, our body sweats. Evaporation of the sweat takes heat from our body and it gives us cooling effect. What we say that water absorbs heat from the body and gives us a cooling. Which type of the energy it is absorbing? That is known as latent heat of vaporization. This energy required to change water into vapor at its boiling point without any change in temperature. That is called latent heat of vaporization of water. How much heat is required to convert water into the vapor? Same amount of the heat is released when steam converted into vapor. That is known as latent heat of condensation. So when we touch steam there, we feel burning at time. This burning is due to release of large amount of heat, or we can say due to high specific latent heat of condensation. Even during heavy rain, that is torrential rain, we have observed so much violence. This is also due to sudden release of latent heat of condensation. When we heat water, it absorbs heat, and when we heat 1 gram of water at 1 degree centigrade, it always absorbs fixed amount of heat, that is 4.2 joule heat energy. And this fixed amount of heat absorbed by water is known as specific heat capacity. And due to absorption of high amount of heat, It is used as a coolant in motor car radiators. And due to this high absorption of heat, or you can say specific heat capacity, land and sea bridges are also set up because large amount of water in a sea and it able to modify climate of nearby land area, that is making them warmer in winter and cooler in summer. Now we will do an experiment where we want to show tap water contain dissolved impurities. For this we need a china dish, a beaker containing hot water. On a china dish or watch glass, take tap water. Keep this watch glass over a beaker containing hot water. Give heating continuously to beaker. Tap water start to boil. After evaporation of water, complete evaporation of water, we will be observe some solid deposited, or we have observed some concentric rings of solid matter. This indicate tap water contain dissolved solid which left after evaporation of water. Tap water, also river water, well water all contain dissolved solid, but rainwater and distilled water do not contain dissolved solid. When you do same experiment with rainwater and distilled water, we do not observe any concentric rings, which indicate rainwater and dissolved water do not contain any dissolved solid. There are so many salts present in water, and these salts are very important in our life. Dissolved mineral and salt are essential for growth of plant. It adds taste to water. It provides essential mineral to our body also. Oxygen and nitrogen in air present in percentage we know very well. Oxygen is 21%, nitrogen 78%. But in water it has a different composition, that is 33% oxygen dissolved in water and 66% nitrogen, 1% carbon dioxide in comparison to 0.01% in ordinary air. By percentage we have observed oxygen is highly soluble in water than nitrogen. We want to show now in experiment tap water contain dissolved gases. For this I need a round bottom flask. Fix a cork having 2 holes. In one hole we will be kept thistle funnel. In another hole pass a delivery tube which will be connect with the another tank. In a tank filled with water, keep a gas jar in a tank. Start to heat tap water. After boiling, we will be observe some air bubbles in a gas jar. This air bubbles indicate presence of gases in tap water. As now we know oxygen, carbon dioxide dissolved in water. It has so much importance in our daily life that due to presence of oxygen in water, marine life can breathe, can respire, Aquatic plant can make their food by the process of photosynthesis to dissolve carbon dioxide. Carbon dioxide, when react with limestone to form calcium bicarbonate, marine organisms such as snail, oyster, can extract calcium carbonate from calcium bicarbonate and build their shells.